Hi, I'm Mike Stanzik and this is Digital Electronics Classroom. In this video, we're going to be talking about number systems and the conversion between them. And we're going to convert between octal and binary, back and forth. And what we're going to find is that there's a really nice shortcut here because of the number 8. So let's get into it. So we're converting between binary and octal. And it's all about the 8s. Okay? So to count 8 digits, we count from 0 to 7. So we go from 0 to 7. So how do we represent 0 to 7 in each of these cases? So for octal, all we need is one digit, and that represents 0 to 7. No more, no less. For binary, to represent 0 to 7, we need 3 digits. And the highest number that we can represent here is 7, and the lowest is 0. So again, no more and no less. So this can only go 0 to 7, this can only go 0 to 7, and so that means that these are equivalent to each other and they can be exchanged directly one to the other. And that is the shortcut that we're going to use as we're looking at converting from one to the other. Okay. So we want to be aware of place value for our binary numbers. So this is the 4's place, the 2's place, and the 1's place. And that's going to be very helpful for us as we do our conversions. So let's do an example. So let's say that I had 5, base 8, so octal 5. As we convert this, I'm going to need 3 binary digits to represent that 5, right? We're going to convert it to 3. Maybe not need 3, but this is our quick conversion. So I need a 4, so I do need this one. And I need one more, so I need that one. So we have 1, 0, 1. So a 5 is 1, 0, 1, base 2. What if we started with the binary number? So if I started here with, I'm just going to do it on this side. So if I started with the number 0, 1, 1, base 2. Well, here's a set of 3. And so this is going to be represented by, let me just give it some headers here. It's going to be represented by one digit, and so we have to figure out what that digit is. And so we have a 2 and we have a 1 here, so we add those together, we get 3. And so this is 3 base 8. So that is what we're doing when we're making our conversions here between octal and binary. So the true power comes into play when we have larger numbers. And so when I look at a situation where an octal has 2 digits, to get from the first digit to the second digit, we multiply by 8. And so this is a factor of 8 change to get to that second digit. And if we do the same thing with binary, to multiply by 8, we have to multiply by 2 times 2 times 2. So that's 3 movements to the left. And so this is a movement of 3 for each of these. And so what we notice here is that one single digit, one character in octal is represented by 3 characters in binary. And they nicely move over to represent those. So just to kind of make this a little bit clearer, in a binary number, where these are sets of 3, each of these sets of 3 is representing one digit in a octal number. And you know what, I don't like how that's drawn, so let's go ahead and make those sets of 3. So 1, 2, 3, 1, 2, 3. Okay, so sets of 3 binary numbers turn into one number in the octal, and even if we have multiple sets, we can do it in that fashion. So let's go ahead and build a number in binary. And so let's use the number 1, 1, 0, 0, 1, 0, 1, 1, 1. Okay. So this is in binary. What is this number in octal? And so we're going to make that conversion. So what I'm going to do is break this up into groups of 3. And there we have 3 groups of 3. So that's nice. And so I'm going to need 3 digits. 1, 2, 3 in octal to represent this. And so let's go from left to right. So we have 1, 1, 0. So remember, this is a 4 and a 2 and a 1. So this is 6. And then we have 0, 1, 0, that's a 2. And then we have 1, 1, 1, that's a 7. So this is 6, 2, 7. And that represents this binary number in octal. So let's go the other direction. So what if we had the number 6? Actually, no, let's change this up a little bit. Instead of starting with 6, let's do the number 1, 3, 4, 5 in octal. Okay, so how are we going to represent this? Well, we need groups of 3 for each of those octal digits. So 1 is just 0, 0, 1. So these leading zeros don't do anything, but we put them in there because this is the method that we're using. This 1 becomes 0, 0, 1. And this 3 becomes 0, 1, 1. And the 4 is 1, 0, 0. And the 5 is 1, 0, 1. And so that's our full binary number. Now, if you wanted to write that, this is perfectly fine, and this is how I would leave it. It shows your method, and you don't make any mistakes in this way. And so these 2 ways are the way that we can convert from binary to octal, and then from octal to binary on the bottom here. Great. So I hope you found value from that, and thanks for watching, and we'll see you next time. Bye.